Thank you. And good morning to you all. It's nice to see you that there are so many of you here around. So my name is Teija Vainio. I come from Finland, from the city called Tampere. And as Alan mentioned, my presentation is about urban planning, how to support citizen participation in urban planning processes, and how to use eye tracking technology for urban planners, architects, designers to understand and communicate with citizens about what is attractive environment from a non-professional designer's perspective. And this is a case study. This case study is part of the Contour project conducted at the University of Tampere or Tampere University. We use both names nowadays. And the project were funded by the Academy of Finland. My co-authors here are Ilari, Karppi, Jokinen, Helena, Leino. All of them are from the University of Tampere, or Tampere University. And Ari and Helena, their background are in environmental policy. And Ilari's background is in administrative sciences. And my own background is in computer science and architecture. So our background somehow describes our views and perspectives into this phenomena, how to use technology in urban planning processes. So I mentioned this case study is about urban planning and filling the communicative gap between professional planners and non-professional planners, particularly when professional planners are using visual representation of the future urban areas. And they are aiming to answer several questions. And our research question in this case study was, what are the strengths and challenges when applying particular technology, in this case eye tracking technology, to gain insights on human attention with planning illustration and photographs that architects and designers are using of urban environments. So we had experiments in two Finnish cities, in Espoo and Tampere. We have around 30 participants, and there were both professional and non-professional urban planners. And what we got as an outcome is this type of results. So this is a heat map describing after 1 second what the participant is looking at. And this after 1 second is very interesting outcome because it's an unconscious reaction or action, actually. And then we see what is the most interesting or what is the first thing, actually, what caught the attention in particular illustration or photograph or design. And this is after 5 seconds in the same place. But as you can see, this heat map describes where the participant is looking at. But this doesn't actually tell us why. And that's very important to understand for designers. What we learn during this case study is that what people find attractive in urban environments is very context-sensitive and subjective matter. For example, if the participant is very familiar with the places beforehand, or if the area that designers are planning is unknown to the participant, it have an effect to how he or she reacts. And by analyzing what physical elements people look at in different environments, we could understand what catch their attention, but we could better understand the elements of urban design quality. And this is very important to the designers and architects and urban planners in general, to understand what is most interesting or what is catching the attention in urban space, when the general aim of is improving the design quality. And what else? We find that this type of technology provides good tools for this type of purpose, to bring new knowledge and understanding, to improve the design quality and understand why people are interested in particular elements in urban environments. And this is another place in Tampere city. As you can see, the results are like this, heat maps, but what the researchers and designers have to do before they get this type of results is they have to define areas of interest. If they are using eye tracking technology, it's important, and this is one of our key issues or lessons that we learned, that when we are defining areas of interest, that has impact how the results are analyzed. And this is one example how we analyze or define the areas, and this is another one. So what are our implications for practice based on our case study? It's very important to design areas of interest so that they support your questions and hypotheses. And above all, you have to define the goals for measurements. Are you interested in security, safe traffic, or attractive environments, green spaces, or things like that? And you must also define if the goal of the element in urban environment is to be attractive or not. This means that, for example, if you have a street view or street area and there are traffic lights, trees, open spaces, and things like that. And then one thing is also that you have to compare areas of interest. This means that, as I show you, there are several areas of interest, and if you compare them, then you might get information or knowledge. For example, is the lighting or the green spaces attractive enough or something like that. And most of all, I think this is the most important outcome of our case study, that you have to analyze the quantitative results with the participants. As you may know that when you are using this type of technology, you have plenty of quantitative data. And you can analyze that with statistics and things like that. But to understand why people are looking at something, it's very important. And eye tracking probably won't tell you that. For example, when we were During our case study, one of our participants looked at a particular door in a street view, and we were wondering why that door in a building is so important for her. And then she explained later on in a workshop when we were analyzing these results with the participants, she told us that her children were taking care in that building. It's a daycare center, for children. And there were some problems with that center in the couple of months. And she was wondering if it's still open or not. And then we realized that, okay, this is a very personal thing for her, and that's why she was looking at that particular target so long. But what it tells to urban planners, well, design doors or not. But I think, and we argue that this type of example gives you the idea that if you are just looking at the quantitative data, it doesn't give you the whole picture. You have to interpret the result with the participants. Yes, I think I leave my presentation here and thank you for your patience, and I'm anxious to hear your questions. Thank you.
It's more of a clarification. Thank you, Teija, for a very nice presentation. And I'm just curious about your participants. So were the participants tested attract in solo mode? So were they alone, where they were looking at space, or were they doing it in conjunction with someone else?
They were solo testing the, yes, how do you think that it will change the results or outcomes?
Yeah, I would imagine that if, for example, you are, let's say, with someone else, like you are in groups, and you are observing something, it's in effect linking very much to the social aspect. Someone, immediately when you're in a group, you assume that you are communicating somehow, and it might influence the way that you are looking at things, because when you're with someone else, and especially when there is a discussion that's been triggered by a monument, or by a sign, or by a bridge, I don't know, like one of the ones outside in the city, that might trigger another layer of, let's say, direction on what you are looking when you are with someone else, as opposed to when you are solo. So that's why it's very much a social behavior, as opposed to...
Yeah. Oh, sorry, yeah. Yeah. That's
why I was asking. I'm just curious whether that is something...
Yeah, that's true. Our study were focusing on understanding how to interpret what is attractive in a visual representation. But maybe we can use this type of experiment set up in the future, because I'm quite sure that this would be very useful to see how the social aspects are affecting that. But in this case study, we were focusing on only on the single solo.
Any questions?
Yeah.
Go, please.
I'm just wondering, because I know in architecture, planning, I also come from urban planning, there's this discussion around what it means to do 2D renderings, and how kind of this criticism around if this is representative of an urban environment or not. So I was wondering if you also want to use this architecture methodology, for example, for 3D simulations and how you think that might change the results of the research?
That's a good question, good comment, because I know that in my hometown in Tampere, they are building a tram there currently, and they want to use three-dimensional visualizations because they are building a tram now. So they have only visualization and three-dimensional models how it could be looked at in the future. And they are interested to use this type of technology, and we agree that it's a good idea. But for now, we haven't used that yet. Some plans to do that.
And one more question, then, please.
So I'm also come from architecture. So I'm wondering, like, because it's known that sunlight is quite a problem or like potential things that will affect the accuracy of the architecture. So have you ever considered, like, for example, are all your consultants doing the experiments with the daytime, or are they all in the same conditions with same light conditions?
Yeah, that's true too. No, we use the same daytime and condition were the same. But that's true that when we are changing, for example, the lighting or have some noise, maybe or something like that, it would definitely affect, or probably, let's say, affect the results. But we haven't done that yet, but that's a good future work also.
Actually, we still have to take another question. Can we get anything else?